Good morning, Medo Yantra viewers. Today we will see ARC-AGI-2 challenge and its performances latestly submitted by Jay Berna. So, if you see last week, the social media and the AI circles went abuzz on Grok4 based submission by Jay Berman outperforming the performance of all other models so far in the ARC-AGI-2 leaderboard or ARC-AGI-2 challenge. So we will see what is this ARC-AGI-2 challenge and how this has performed at the level that beats all the models. Okay, what is the methodology we will see? We are not going to measure them because the measurement is private, semi-private, and also public. So we don't have the private data, so we cannot measure it independently. So what we will do is we will take the publicly available information only and go through and understand what is this challenge all about and why it is very hard for models which are mainstream models also to uh, perform at this rate for the given challenge. So coming to the leaderboard as on today in the ARC-AGI 2 challenge, at this point of time the J Bernan submission is at the 30% score at the top level, and followed by EPANG 2025 again, and followed by the Grok4, which is a thinking model per se. Okay. So let us see what is the challenge it all together now. So ARC AGI 2 challenge is basically the capability to measure the reasoning capabilities of the models and play them on an unknown, unseen uh, inputs. So, for example, the test cases itself, there are around 400 training tasks and 400 evaluation tasks. The training tasks itself are typically based on a 30 by 30 grid. Like you see here, there can be 30 pixels by 30 pixels grid, and in within that particular grid, you what you see is basically the various patterns which are given, and there is a inbuilt logic that is there to for the model to decipher, understand, and apply them on the inputs. Okay, input to infer. Okay, so when we are trying to do that, the inputs and inference outputs, with whatever are there, the rules needs to be known. They cannot just memorize the patterns because the inputs are always unknown to the model. So it is not available in the training data, and these are inputs. So if you take the example of this particular one, okay, this particular example, if you see in the first example input, the second output, and second example input. So what we are going to see is the patterns are very, very different. And like, there is no relation also to the shapes. What is there? What is the relation here is all those in the first example, all those does patterns or smudges, they are there, which does not have any hole in between are colored yellow. With the two colors, they are colored green. With two holes, which are one hole, they are green. With two holes, they are colored blue, and three holes, they are colored orange. So that's what is the logic that is followed in this particular example. Okay. So same happened here, and now as a human, we can predict what output it is supposed to go. But for a model to understand, think, and comprehend these rules from the inputs and make a specific rules, and they performing on an unknown data set is very, very hard. So that is what is the bigger challenge, which they call it as ARC-AGI-2 task. Okay, tasks or a set of challenges for the model. So ideally, what they will try to do is, because the challenge itself has three restrictions or three hoops to jump. One is it will aim to resist overfitting and memorization. So, what if I just memorize the tasks and go ahead and do the overfitting so that I perform? No, that won't really work. Okay. Because the overfitting and memorization, you don't have enough data to do that particular one. That is one challenge. And the second thing is the challenges are in such a way that you have to learn based on the rules of the n plus 1. So if you know, if you want to memorize, you need enough number of samples, isn't it? So, and you cannot even prepare, should not be able to possible to prepare for the tasks in advance. So every task is unique. So in that case, you cannot, do a memorization, or even similarity index or a categorization based on the data. Your data samples itself are very small, and your outputs are always unseen. So that's the reason. That is what is the defining characteristics. Next is you cannot use your prior knowledge there. Okay, like cognitive priors or a object persistence or goal directedness or basically number based game or angle based game. So these you cannot really do. And the third challenge is you should not have any specialized world knowledge. So, if that is there, models or large parameter models will outperform the small parameter models, isn't it? So, therefore, what they did is they put the set of the data to build in more and more cognitive understanding. And then all these challenges, not just by the machines, they should be able to be solved by the regular humans. I would say a human that is who is about 10, 12 years of experience, even 6, 7 also years also can do with clues, but regular humans without any special training, without any knowledge, without any background like a IT or engineering background, they should be able to do. So that is what is called a general fluid intelligence, and that is what they say. If you are able to figure out from the given training sample set, then you are almost thinking like a AGI kind of a scenario. Okay, so basically, this does not mean a real AGI, but when you say this test has been passed or this test has been accurately done, it means the fluid intelligence capabilities of the model are almost at a human level, or they possess the right constructs for the AGI. Does not mean it will learn and everything, but it says the constructs that are required for AGI are in place. Goes ahead and tries to stop k-means or k clustering kind of a scenarios. So what it does is, let's take this particular example. If you see here, it looks like a clustering. When you see output one, input two, they are just getting clustered on some areas. So output two, output three, also it's like a clustering. But what is the logic here? I just wanted to tell you that what they are doing is basically they have a internal order of, ordering the things. So the border color of the boxes are being ordered. Then you cluster them as per the border color of the axis, and then you move it to the left side box. Okay. And when you are moving it to the left side box, never ever reorder them on the vertical line. So that is why you see in the example one, these boxes are moved here, these boxes are moved there, and if there is a boundary conditions, you just have to replace them there. You cannot change the X line. Like if this is the X line, and you cannot change the Y coordinates. So machines which are trying to learn from these three inputs should understand that, okay, you cannot change the Y coordinates, but you have to arrange them as per the X coordinates. So there are six chained rules here, and that's what is the challenge which the machines should learn from the data set. You cannot code them, you cannot write the rules, you cannot write the uh, if else conditions. You have to learn the rules which are intuitive in the test set. And that's the challenge. If you understand this in detail, it's called contextual rules. Okay. RKJ2, and basically it makes you to force to understand the contextual rules, and then you go ahead and apply the conditional rules derived from the context. So there is no predefined rules, and you have to derive the rule from the context is the biggest challenge. So the next challenge is basically multi-step compositional reasoning. So, for example, if you see here, okay, you have several shapes and you have to compose these, just like you are arranging Lego bricks. So, what you are supposed to do here is, the training examples are pretty simple for a human. You have to understand, you will have to pick up right connectors here, like here, if you see this yellow box and the blue box with the 90-degree angle connectors, you just have to match the connectors so to make a shape of a form. If you just match the connectors and put a block, that is the answer. But to do that for a model, it is very, very impossible, because and you have to do it quite iteratively, so you cannot do a brute force algorithm. So that is one of the multi-step compositional reasoning this ARC-AGI-2 tasks are having. This is the challenge. So this was attempted by many models, and many models, I know out of many models, people, they were not able to reach to that particular position, or the kind of a execution Grok 2 has reached. Okay. So that is why the entire, social media is gung-ho on that. Elon Musk went ahead and claimed that if you are going to put Grok 5 training, we are going there and all and all. So that's what is the challenge as of now, which Grok 2 has done. We will also see one more example to understand what kind of a challenges it produces, so that we know why and how the answer is also done. Okay, we are taking the answer from his substract, so we also know how he attempted to challenge. So one more challenge here is like this, where there is a shape and you have all the unfilled shape blocks. So the model has to come, pick the shapes and apply the transformations on it, and see if that fits into the box, and all the available shapes you need to fix, and the things which are not related you just need to put it out. So for example, in the example one, if you see on the left side, you have to rotate the blue color, light blue color shape by 180 degrees, and the square shape fits properly, and the L shape, green color L shape, you have to transform by 90 degrees to fit into the output. Okay. So if you see, this is a multi-step compositional rule again to get the maze fixing. These shape fixes are done by 3 year or 4 year olds, typically 3 year, 4 year toddlers, human toddlers will be easily doing this task. But for a machine to do it, or for a model to do it accurately, is a very, very hard story. So that is what is the hoop which is there. And that is the reason compositional fluid intelligence with a smaller set of data for training is the challenge with the ARC-AGI 2. And that is why this is celebrated. So, Jay Bernan has used the Grok 4, okay, to get to a process, and that process output has given you the answer. So, what he has done is he has built a system that works like using the Grok 4 generate natural language instructions for each of the tasks, and there are multi-agent system, which scores the generated instructions itself, and all those work in a way to pick up the best performed instructions. And then now, we take those best performed instructions and then regenerate the new instructions with that, And finally, you have got, after multiple evaluation is cycled, there are about 40, 50 instructions which are there, long instructions. And then you just apply those as a 36 dynamic prompt per task. Okay. So whenever you are going to see, it's kind of a brute forcing of, whether you are figuring out or not. But yes, like this is done by a solution which is a AI solution. Yes, the instructions are 40 candidate instructions and dynamic prompts, but those prompts are generated by looking at the challenge. So therefore it is called machine intelligence. And then if the challenges like, what if the new task come, you have to retrain. What if the unseen task comes, it may not know the answer. Those all exist, but with the given testing cycles, the in the ARC-AGI-2 challenges, Grok4 based J. submitted has come up to 36 to 38% of accuracy, which is staying in the leaderboard. And that's what is creating this kind of a buzz. And obviously, Grok 4, Elon Musk went ahead and marketed it like no one other. So I appreciate him on that thing. And to specifically say, Grok 4 did not do it. The Grok 4 application has done it. Now, if somebody, what would happen if OpenGPT guys try that? Or what would happen if DeepSeek tries that? What would happen if some other models tries that? I don't know the answer, because this is not a direct Grok 4 thinking application. It's a Grok 4 based solution that has achieved this. Okay, so that's all for today, guys. We will keep this space monitored, and if there are any new challenges or new developments, and if the leaderboard changes, I'll come back and tell you within a video. But up till now, thank you for the attention, and thank you for reading the Vedoyantra videos. Now, please do subscribe and observe us for the simplified AI stories, AI news, and AI articles. So, if you want any specific question around the AI to be answered, please feel to comment or request us so that we will make a video answering your questions in the AI world. Thank you. Thank you once again.